I have learned a lot about the legacy of the University of Utah in genetics research, which is really incredible and has set a foundation for a lot of really exciting advances. So when I came to Utah, I really wanted to work on diseases that are impacted by environmental change. And valley fever is dramatically impacted by changing climate and increasing cycles of drought and precipitation. Valley fever is a fungal pathogen, so humans can get infected when they inhale fungal spores that are found in the dust and the soil. There's no vaccine for the fungus, and so that means from a public health perspective, really the best thing we can do to prevent disease is raise awareness. So we're leveraging this elevation gradient in Washington County, Utah, which is the county with the highest rate of disease in the state. And the gradient spans Utah's lowest point to the highest point in the area. It's bad for respiratory health to inhale particulate matter. It's also dangerous if it includes these infectious fungal spores. Protecting our public lands, especially lands adjacent to population centers, is a critical public health measure.
Our lab works on HIV, and when we started in 1992, that was an acute problem. So one of the great accomplishments of biomedical research, not in our lab, but in general, is that HIV is no longer a death sentence. People are now in the developed world treated effectively and can go on to live relatively normal lives. Our lab works on a structure called the HIV capsid that's essential for viral replication. And we were then contacted by Gilead Sciences, who agreed that it might be a good drug target, and they've worked for more than a decade to develop really potent inhibitors of HIV capsid. And a few years ago, they were approved for people who are HIV positive. That was a great step forward, but the real promise is in preventing HIV transmission. And that's a big need. 1.3 million people every year get newly infected with HIV. And so their drug, which is called lenacapavir, protects people for 6 months after a single injection, almost completely from becoming HIV positive. And of course, it's much better to prevent HIV infections than to treat them. So we have this amazing legacy. We have an amazing legacy on the medical side, but also on the research side. So Mario Capecchi is the most famous example. He had this revolutionary transgenic mice that ultimately led to the Nobel Prize. I see the future as being limitless. Utah is a high-growth state. The economy is doing well. We have an educated population. People really care about making new discoveries and translating them into human health. So I just see no reason not to be sort of wildly optimistic about what we can do.